Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, we are going to discuss about a very important topic, that is the mass concrete. Nowadays, the mass concrete is widely used, but how to select the right kind of material for the mass concrete? What is the criteria for the design? That today's video I will discuss each and everything about the material selection of mass concrete. So stay tuned until the end to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So let's jump into the subject that or reduction in the long-term strength as a result of elevated concrete temperature due to heat of hydration. Now, it's given the clear dimension or the clear direction which concrete can be called as the mass concrete. Now, all you know that whenever the concrete is producing, whenever we are adding water into the concrete mix or into the cement mix, what is happening? The cement and the water start mixing or start reacting. Now, this reaction is produced heat, so that is called the heat of hydration. So whenever this reaction started, so any volume of concrete, the heat of hydration will be there and heat will produce. Now if there is a limit, if heat is excessive, then what will happen? The ambient temperature and the concrete temperature, there will be a thermal gradient. So if there is a thermal gradient, then what will happen? The heat will transform from one place to another place. Now, as per the heat of hydration, the concrete temperature is always greater than the ambient temperature. So what is happening? The heat will transfer from the concrete to the environment, and whenever it is passed, then there will be thermal cracks. The thermal cracks will generate. That is called the thermal cracks, and it is widely, or it is a common phenomenon for the mass concrete, that the heat of hydration is more, and if heat of hydration is more, then there will be thermal cracking. So that is a recent characteristic concrete mix. Ambient condition can lead to undesirable thermal stresses. So depending upon the thermal gradient, if there is can be an undesirable thermal stresses, cracking, deleterious chemical reaction, or reduction in long term strength. Why? Because if there is the crack is generating, that means this crack will be a prone to chemical attack, and if chemical attack is there, their strength and durability will be a problem, or it will be a reduction in strength and durability. That is why the ACI has given the definition that the temperature is shown as a result of elevated concrete temperature due to heat of hydration. So these are the definition about the mass concrete as per ACI 301. Now, what will be the thermal gradient? Now, there will be a limit. What will be the maximum temperature for the concrete, and what will be a thermal gradient in between concrete or to the environment? That guideline is given in our Annex C, our code IS 16700 2023. So what he is given? The concrete used in massive wrapped foundation, thick shear walls and columns, deep beams. So it is not saying this only the wrapped foundation, but if it is the deep beam, shear walls, column, that will also be considered as a mass concrete. So what will be the shall be designed to appropriately control the evolution of high heat of hydration. So it should be designed for the heat of hydration or high heat of hydration, and its concrete also to be designed as per the heat of hydration should be lowered. The design of such concrete shall be done in such a manner that the peak temperature in concrete shall not exceed 70 degree, and the thermal gradient within the concrete mass does not exceed 20 degrees centigrade. That means the maximum core temperature or the peak temperature inside the concrete have given the guidelines in as per IS 16700 that should be maximum 70 degree. Now, and the thermal gradient, see, all we know, the in the core of the concrete, heat is producing more and the temperature rising is more, and compared to the core, in the surface there is a lower temperature. So maximum temperature can be in the core, it's 70 degree. And what is the thermal gradient? That is saying it is a 20 degree. That means the surface and the core, the temperature difference to be maximum 20 degrees centigrade, and as well as to the environment also. So if this is happening, then what will happen? We can control the thermal cracking. Otherwise, again, it will be a problem for the thermal cracking. While appropriately designed mock trials shall be conducted prior to actual concreting to demonstrate that these parameters are satisfied. So before doing any mass concreting, you need to do a proper mock-up to evaluate what will be the peak temperature, what will be the thermal gradient, and then only you can do the concrete. So I have made a detailed video on that. What is the temperature gradient, what is the thermal gradient, what is the temperature control and temperature monitoring. I have made a detailed video, link is there or in the description. You will get full information. So this is about the mass concrete in definition as per ACI 301 and 16700 2023. The next section is what dimensions are considered to qualify as a mass concrete. Now it is a common questions, and what will be the maximum 1 meter, 2 meter, 3 meter, what will be the maximum minimum depth that to be considered as a mass concreting. No, it is saying in as per SI, any size to require to stop outward flow of heat to maintain adiabatic condition. Now what is adiabatic condition? That means the adiabatic condition is that the inside the concrete neither heat will transfer to the environment nor the heat will absorb from the environment. So that is why it's called the adiabatic condition. So any size you need to maintain an adiabatic condition inside the concrete, that concrete is called the mass concrete. But in general practice, greater than 1 meter thick, we are considered that it should be a mass concrete. But again, there will be no minimum dimension or the maximum dimension is mentioned. So you need to evaluate that what will be the heat of hydration and how you can manage the heat of hydration. That will depending upon that you can consider that it is a mass concrete. So that is what dimension are considered to qualify as mass concrete. Next is what is the factors considered during mass concrete pours. Now it is very much dependent that what is the factor we should consider whether we are considering the mass concrete pour. First is the concrete supply. That should be continuous concrete supply. We cannot keep the concrete open. Then the casting sequence. What will be the casting sequence? That is also a minimum evaluation criteria for the mass concrete. If the casting sequence is not proper, then again the thermal crack or the thermal gradient will generate, and again there will be thermal stresses. Then it is coming to the cold joint, then plastic settlement, heat of hydration, and early age thermal cracking. So these are all the things you need to consider during mass concrete pour. So before mass concrete pour, we need to consider this criteria. We need to plan properly. We need to plan well ahead to mitigate all this. So if there is a concrete supply problem, if there is a casting sequence problem, or there is a cold joint is providing, or the plastic settlement is happening, so that are all the things we need to consider before pouring the concrete. We need to plan accordingly, and accordingly we need to do the concrete supply and concrete pour. Otherwise again the thermal gradients will create and the thermal cracks will generate. So these are the factors we need to consider during mass concrete pour. Now what is the materials for mass concrete? Now why we are thinking what is the material for mass concrete? See, what is our target? Our target is that we need to lower down the concrete pour temperature. So that is why we need to consider, or we need to select the material which is given the lower temperature or the core temperature or the surface temperature. So we need to consider the material which will produce less amount of heat due to heat of hydration. So one thing is we can use the 43 grade of cement. That is, if you use a 53 grade, the heat of hydration is more. So we need to choose. Also we need to think about the criteria for the strength and durability. So it is advisable, and you can use the 43 grade of cement, so it has the lower percentage of heat of hydration, so it will produce less heat. Then low heat cement. Again, it is a criteria, this low heat cement, which means we are producing the low heat or the low heat of hydration. So what is low heat cement? That is, we have the less C3A and C3S. So what is the composition of the cement? All we know, the C4 A, C3S, C3A and C3A4AF. So these two amounts, C3A and C3S, is given the more contribution towards the heat generation during the heat of hydration process. So if this two amount is less amount, then there will be a less heat producing, or heat of hydration will be the less. Then supplementary cementitious material. Now it is always advisable that we should use the supplementary cementitious material like pulverized fuel ash, GGBS, microsilica, or what is the benefit? There is two benefit, that these are all the byproduct. So we are using the byproduct, so we are giving the environmental sustainability. And another way, these are given the low heat of hydration. So temperature of the heat will be, temperature of the concrete will be the less. So that is our target, to reduce the temperature of the core, so that there will be no thermal cracking, there will be no thermal gradient. So then there will be no thermal heat pass, then there will be no thermal cracking. So we are using the supplementary cementitious material. Then retarding admixture, that is also a good, you have to reduce the heat. And then super plasticizer for SCC, that for the, if it is a self compacting concrete, then we need to use the super plasticizer, or in other cases we can use the normal plasticizer, but for the SCC we need to use the super plasticizer. Then cold water and ice. Now why cold water and ice? Now, what is our motto? Our motto is to reduce the temperature, or reduce the heat of hydration. Now, there is two part. One is the pouring temperature, and another is the heat of hydration. When the hydration process is started, then there will be what will be the temperature. Now, first things, we need to lower down the our placing temperature or the pouring temperature. Why? If the pouring temperature is less, then the peak of the heat there, that will also be the less. That is why, as much as we can, that we need to lower down the our pouring temperature or the placing temperature. But how we can do that one? We can do it by reducing the raw material temperature whenever it is mixing. So how we can make? We can make aggregate sand, that is to be stockpile, to be in the under shade. Direct sunlight will not be there, so there will be temperature will be less. Or we can sprinkle the water above the aggregates, and then again we have to calculate the moisture correction during the pouring of that, so there will be no water cement ratio will be increased. So that is where we can reduce the placing temperature. Now the best way to reduce the placing temperature, to use cold water or ice. Why ice is better than the cold water? Because our latent heat of the ice is 540 kilojoule. So whenever 1 gram of water and 1 gram of ice, there is a difference of 540 kilojoule of water heat. So this ice, when it will melt, it will take the warm latent heat from the heat of hydration, from the mix. So the temperature of the pouring concrete will be less. So then the our peak will also be the less. So that is why it is important to use the ice or the cold water. Better is the ice water percentage, what will be the. But why ice? Because you see, ice is also maybe only 180 kilogram or 180 kilo in between. What is the mixing? This maybe is 200 2400 kg in 1 cubic meter, compared to water is only 180 or 160 or 70 like that. But still, if we are using ice, because it's the latent heat or the specific heat is more, it's 1. And for the aggregate it is 0.2, sand is 0.22, cement is 0.20 to 0.25. So the specific heat is high with water, so that is why it has the capacity to reduce the core temperature or the concrete temperature. So that is why either cold water, or it's better to use the ice. So in this way we can reduce the pouring temperature or the placing temperature, so that the peak will not be that much, and again there will be no thermal gradients, or the maximum temperature or the peak temperature will not arise. Then our concrete will be safe. So these are the material for the mass concrete. Then another that is thermal cracking, that we need to consider. What is thermal cracking? Why thermal cracking happen? Then thermal cracking can happen for as the reason of heat of hydration, already I discussed. That is, if there is a peak temperature is more than 70 degree and thermal gradient is more than 20 degree, then that there will be heat transfer, and if there is a heat transfer, the thermal cracks can be generated. Then the resistance factor, it is a very much important in the mass concrete, that is the resistance factor. If we are not properly restrain the concrete, then there again thermal cracks will generate. So what is resistance factor? The resistance factor in concrete constructions refers to the degree to which the movement of a concrete element is restrained or restricted or restrained by external or the internal factors. It qualifies how much the concrete is prevented from expanding or contracting freely due to temperature changes, drying shrinkage, or other deformation. So that resistance factor is also very important in the mass concrete for the thermal gradient or thermal the crack. So resistance factor is dimensionless value, and that ranges between 0 to 1. 0 is integrated, no resistance, that is concrete can move freely, and 1 indicates full restraint, completely restrained movement. So I have said already there is two kind of restraint. There is external and another is internal. So what is external restraint? Caused by adjacent structure or support that restrict movement, that is walls, foundation, etc. And internal, caused by differential shrinkage or temperature gradients within the concrete mass itself. So that is the internal restraint. Now I have get this figure from the books of this is Barnford or Chris in the 1988. So this has given the very clear cut idea that what is called the restraint factor. See, external based restraint dependent on length and height ratio. What is the length and what will be the ratio? And internal restraint from vertical temperature variation. And then this is the internal resistance from temperature variation through thickness of the wall, the center and the surface. So through thickness of the wall, what will be the internal resistance? See, here is wall thickness, and these are the internal resistance factor. Now combined resistance by superimposition by A, B, C. This is for the external based resistance, internal resistance, and the internal resistance from temperature variation, and for the vertical temperature variation. So if we combine, we are getting this type of resistance. So the superimposition internal and external resistance of the mass concrete. This is very much important. Whenever you are dealing with the mass concrete, you also need to consider what type of resistance of the structure. That is also very much important, because if you are not considering the resistance factor, then again there will be a problem. So another thing is temperature control. So what is how we can call temperature control and temperature monitor? I have made a detailed video already, I discussed. Check that one. You will get the full information how to control the temperature and how to monitor the temperature. And in Barnford there is given in a beautiful formula. This is the simplest approach to the object of limit resistance locked in therm is associated with stress, may be lead or cracking. So from this formula also you can calculate what will be the resistance factor, and from that you can also design your concrete, and you can also make how much resistance you need to protect your concrete from the thermal cracking. So these are all about the thermal cracking. Now we need to do the quality control of mass concrete. So what is quality control of mass concrete? That is very much important. You need to do planning and monitoring. In importance of thermal control plans, monitoring temperature gradients, and using sensor to detect the monitor the temperature inside and the thermal gradient, what is the outside temperature, because it is very much important. If there is a temperature is high inside the core, if you are considering that if you are making this all this mock-up and everything, you are getting maybe 65 or 62, but actual pouring you are getting more than 70. So what will happen? Then you need to do the precaution. You can embed it before concrete, you can embed it as steel tube pipe, and from from that, if whenever the temperature is more than 70 degree, or you are saying that it is coming 60, 65, it can go more 70 degree, you can pass the cold water to reduce the concrete core temperature. So that is why your planning or monitoring of temperature is very much important. And staging and tender slam test cube test, that is all as per the requirement. And inspection and documentation, ensuring adherence to specification, maintaining detailed records and everything. But you need to monitor all the time what is the temperature, and accordingly you need to play, or you need to supply the cold water to reduce the concrete core temperature. So in short, about the material selection of concrete: what is mass concrete, what dimension are considered to qualify as mass concrete, factors to consider during mass concrete pours, material for mass concrete, thermal cracking and quality control. And I hope you find this useful about the mass concrete. And if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me. Before going